In this video, we are going to see how we can collect audio data by doing some actual recording using our PC or laptop. So for that, you need a microphone, something that is already built inside your PC or laptop. Hopefully it works. And then you also need some software that can extract that data from that microphone. It's basically a sensor, and it takes the data and saves it into a file. For that, we shall use the software called Audacity, which is free and available for all the standard platforms, Windows, Mac and Linux. You can just install it for your machine. It's a very useful software and I strongly suggest that you install it. Now I have it installed, so I will just fire that up and then I will show how to use it. Now I am in Linux, so I am just typing the name Audacity in the command prompt, hitting enter to start Audacity. If you are using Windows, most likely you will just double click on some icon on your desktop. So this is how Audacity looks like when you start it, and I shall start recording by clicking on this red dot. So let's click it, and immediately Audacity starts recording. You can see my voice, that's why all these ups and downs. So this is not just pure noise as we did in class, and to stop the recording I will hit this button, stop, and you can even play this. So let's just quickly play it and see how the sound sounds like. And immediately Audacity starts recording. You can see my voice, that's why all these ups and downs. So this is not just pure noise as we did in class, and to stop the recording I will hit this button. Now you can see these regions, these are just pure noise regions. So when we worked in class, we just took these things. So you can understand that this part is Gaussian and these are all sorts of non-Gaussian things that I am throwing in. Okay, now I have to just save things. So I will save it by, I will go to File. Now to save it, I will go to Export and not Save Project. So go to Export and there are different options. Choose Export as WAV, W-A-V, which means save the things as it is without applying any compression. We want to do mathematics with it, so we do not want any fancy stuff done to this. The file size will be large, but we will get the raw data. Export as WAV, and it asks for some file name. Well, I will just override this room.wav and I will just say save. It says something already exists, I am overwriting it. It asks for certain fields. If you are trying to make an album or if you are trying to play this sound in some player with various fancy displays, then all these things will be shown in those displays. But we do not care about them, we just hit OK. And it has been saved. It has been saved in a file called room.wav. So let's quickly have a look at that file. So I am in Linux, so my interface might look a little bit different than what you have. So this is my room.wav and I can open it with my player. And immediately Audacity starts recording. You can see my voice, that's why all these ups and downs. So this is not just pure noise as we... So you just now heard the sound using some default audio player that I have. Now I am interested in getting the number. So let's quickly see the size. It is a 1.12 megabyte file. So I want to extract the number so that I can do statistics with it. And for that I will use R. So let's fire up R. Now I need a package to do this. And the package is called TuneR. So I will first write install packages, then inside quote I will write down the name. The name of the package is TuneR, and by default you will not have that package, so you'll have to do this. And when you do this, make sure that you are connected to the net. You hit enter and then it will just install. I already have it installed, but just to demonstrate what happens, I will hit enter. In that case, it will start downloading the stuff and compile and do all sorts of fancy stuff, and finally it will actually have the thing installed. So it downloaded, it is compiling it, and at the end it should say done tune R. If there you get this line, this means everything is okay. If not, you will possibly get some error message. The messages that you saw would be quite different from one computer to another computer. Anyway, it is now downloaded and installed. Now what I will do is I will load it inside my session. So library tune R. The install packages command needs to be issued only once for one computer. But the library command needs to be issued every time you start R. So the install package remains in your hard drive and the library command loads it from your hard drive. So library, the name of the package, but this time without any quotations. You hit enter and it just silently returns the prompt. So when I did install packages, I used quotation, double or single. In the library command, I am not using quotations. Okay, now tuner is a collection of lots of different functions to work with audio files. The only function that we need here is called read wave. So I will use that function read wave. Just notice its spelling carefully, read in lowercase. Now when the next word starts, you are starting with a capital letter. Read wave, then the name of the file, which is room.wav, the thing that I saved. You see, I'm always using this abbreviation, WAV, without the E at the end. But in this function, I have the E. A little bit confusing. Now I have to save it somewhere, so I save it in some variable which I say call my sound. That's a variable name that I created. I hit enter and the entire file has been read into the memory and now you can look at the numbers. Just a word of warning, in this case my default directory or working directory was this, and that is precisely where my room.wav file was also saved. If it is saved in some different folder, you need to go to that folder by first doing set working directory blah 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 whatever thing and hitting enter. But for me, I am already set up in the correct way, so I saved the file in the folder where R will look for it. Okay, now let's take a look at what is inside my sound. STR, abbreviation of structure, will show you the structure of any R object. So in this case, I am going to see the structure of my sound, and it says that after some blah 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 thing, it says left and right. The right thing is empty, num 0 means nothing, and in the left part, because my laptop has two microphones and it used only the left microphone, I had specified that in Audacity. In fact, that was the default that was set up. So it was only using the left one, and it has got these integers, this many integers, and these are some of the values. So you can think of the microphone as a membrane that is vibrating when it is hit by air molecules, and its position of the membranes are actually measured in some unit. Now it is not stereo, it is a mono sound, that's why I do not have left and right, so stereo is false. This is important, this is the sampling rate, this means per second 44,100 measurements are made, so this is actually in unit hertz, that is 44,100 hertz. And each integer is stored using 16 bits, and PCM means whatever data was collected by the microphone has been stored verbatim without any modification. Abbreviated to PCM, nothing to do with Prashanta Chandra Mahalanavish. It's short form of pulse code modulation. Okay, so our interesting thing is inside the left part. So I can take a look, my sound at the rate left. These are all the numbers on which I can do statistics. So for now, I will just make a little histogram of this. So I will say hist, and being a statistician, I always want my histogram to have total area 1, which is ensured by typing prob equal to true, probability equal to true, hit enter, and I get this histogram. Now, if you remember the histogram that we found in class, it was nice Gaussian, and here it is not Gaussian. We have two kind of ears on two ends, and that's natural because there we are working with only noise. Now you are dealing with my voice, and my voice is not IIT, it's not normal. So you can see that there is something else sitting on top of the noise. You have a lot of noise here also, but there is something else as well. Okay, so that's all for this video. So I just quickly told you how you can collect audio data using R and using Audacity, and you can later analyze it using R.